I hit my microphone. That's not good.
Shooting our eyes out with sketchy lasers.
Welcome to the Hackaday podcast. My name is Mike Szczys. I'm editor-in-chief of Hackaday.
Hi, I'm Elliot Williams. I'm managing editor of Hackaday.
This is episode 107. Today we're talking about FTDI plays music, LED dimmin' ain't easy, measuring poop calories, and sketchy laser cutters. Elliot, did you see that robot land on Mars?
Oh, dude. I actually watched it live. It was like 9:30 at night here, and I was downstairs. I brought my laptop down to bed, and my wife and son and I all watched it live, and we were
awesome.
like, where's the pictures? Where's the footage?
Yeah.
And then they like finally put up those pictures out of the hazard camera, and Max was like, what? It was way past his bedtime. He was like, was pictures of Mars. And she and I, my wife and I, were like, where's the video?
Yeah. I watched it live too, and it struck me right away that me as a nerd watching NASA nerds watching computer monitors, I'm like, this is the geekiest thing ever. But it was still awesome. And like, I was chatting with Tom Nardi on text while we were both watching it, and he's like, and you know, the thing is either already landed safe or crashed because there's a 3.5 minute delay or whatever.
11.
Is it that much?
It's super long.
Yeah.
The thing is a pile of wreckage by the time they even notice.
I was talking to a good friend of mine about it, and he just was not grasping the importance of it. He's like, well, I've seen them do the test runs on Earth, so like, why wouldn't it work on Mars? And I'm like, oh my God, seriously, no, wrong? It's like so much harder. Like, they packed that thing up. It's got to go through interplanetary space and be super cold, and then you don't get like a test run to see if everything's working. I mean, you can run analytics and stuff when you wake it back up, and then there's no live control as it goes into the atmosphere. Like, it seems like a super hard thing.
Yep.
But I got to tell you, one of the coolest things that night, Steve Collins, the long-haired NASA guy on Twitter, posted an image from the satellite around Mars that took a line scanned photo of the surface and caught Perseverance with the parachute open during the landing procedure in like Bigfoot grainy footage type of stuff, because you have to zoom way in. But it was just the thought of like the orbital mechanics of sending that thing from Earth to Mars, getting it to land on Mars where you want it, and then like at the same time having this satellite take a picture of it in that, you know, couple minute period where the chute is open and it's going down, and having it come out and then sending that image back to Earth and then putting it out so that a Cheeto stained hand guy on his couch, me, gets to look at it on his phone. It was just the coolest thing.
Yeah, it's pretty awesome. I really like the video because, you know, you get this slow descent into Mars, and you can kind of appreciate just how rocky/dusty it is, and just pockmarked everywhere with craters, which totally convinced me that I'm not going to go to Mars at all, because you get one of those things that makes those craters on your head. You're having a bad day. But then it gets close enough and it lands, and you can see it doing the sky crane mess. And then there's just this swarm of dust on the ground, and they're lowering the rover into the swarm of dust. And I'm like, my gears, my gears, I have dust in my gears.
Oh, what an accomplishment. So congratulations to all of them. I thought the footage, the high definition footage that was coming out the Monday of this week, about the landing experience, and they went through it. You know, there were some cool things like the red and white pattern on the parachute has an Easter egg, like a coded message in it, which is cool. But you just get them to talk about like what's going on as you see the video coming. And it was inspiring. Congratulations, and we can do hard things.
I'm oddly amazed by this, but my dad also had these like panoramic images that came back from Viking 1, Viking 2, one of those two anyway, that he had printed up and put on the wall in his lab. And I kind of grew up with the idea that you could look at pictures of the Martian surface somehow. And in some way, we haven't come super duper far. I don't know. I'm trying to parse this, how I feel that it's super incredible to be putting remote robots on other planets at all. is really crazy and futuristic sounding to me in one sense. And then the fact that we've kind of already also done this 40 something shit almost 50 years ago now.
Well, we're going to pack you up in a cube, Elliot, and we'll launch you on the next one. So we'll put Elliot on Mars.
No, sir. Remember that bit about the meteor craters. I'm not there. It's so dusty. It's not the place for me, man. Not the place.
All right. From wonderful news to not so wonderful news, we also found out on Wednesday that Fry's Electronics has gone out of business.
Oh, Fry's.
Have you been to a Fry's?
Yeah, I used to live in San Diego, and we had a Fry's over in, I can't remember, La Mesa, El Cajon, a little drive over. It's like, thinking about Fry's kind of encapsulates the Southern California tech thing for me. Like, that's like going to buy a fancy new graphics card in the early 2000s.
So kind of like a Comp USA.
Sweet, sweet memories. Exactly.
Yeah, I remember that. Yeah, so it's sad to see it go out. You know, Kristina picked it up and wrote an article about it. And I think it's nice how she ended that, which was, hey, there's still surplus stores dotted all over the place, and let's show our support of those. So there's a bunch of people giving their well wishes. I talked about Axman Surplus in Minneapolis, which was one of my favorites when I lived there. Of course, we wrote an article about Tanner's Supply in Dallas that actually went out of business about a year ago. Unfortunately, it was a wonderful shop. I was there. You know, these are gems. If we can keep them going, it's nice to have a local place for all of the electronic geeks to congregate.
A lot of the surplus electronics people are kind of labors of love run by the people who run them, which is a double-edged sword. It means that the person behind the counter loves electronics and can give you super good advice that you can't get from like random sales drone X. But it also means that when they are ready to hang it up and retire, the business closes because nobody can take it from them. And that's what happened to Tanner. That's what happened to, I think, Javanco in Nashville, where I grew up, is out of business now. You know, it's kind of a weird thing, but because they're these like small mom and pops run by a real person, they've both got the advantages of that, but then the disadvantages of not having a giant corporate chain behind them. So definitely go out there and give them your money, because they's good people.
Well, let's jump into our first featured hack today, Elliot. It is the Internet of Clams.
Yeah. What?
This is a wonderful overview. It's not a particularly new thing, but I had no idea that this was going on, and it has to do with sentinel species. So this is like using another organism to tell us something. I think the canary in the coal mine is the cliche one that you think. Miners would take canaries in little cages down in the mine, and if the canary keeled over, it meant that there was gas that you shouldn't be breathing. You should get out of there. This time around, it's clams used to monitor for pollutants in water, because there are certain species of clam that are very sensitive to this and will close up. They'll clam up. And so what they've done here is just glued a spring to the shell of the clam and then put a contact at the end of that spring. And if the clam closes, that contact will come down on its mating part, completing a circuit, and you can monitor that electronically.
I love it. Did you see the crazy video attached to this?
Oh, I don't know. I didn't watch it. It's a preview for a documentary, right?
I just watched it on its own as if it were an entire freestanding piece, and it is hilarious.
It's 49 seconds. I got it rolling now.
Yeah, go watch it.
All right, Elliot, through the magic of radio, I have now watched it, and it was excellent.
It is the most Polish psychodrama of being one of these clams that's in the water sensor. It is the funniest, most like totally serious, absolutely deadpan funniest thing I've seen in a long time.
So I will have to say the best thing about this is how you get better resolution from the clam sensor.
Okie dokes, what's that?
You add more clams.
Redundant clams.
Yeah, so they have, one installation has 8 clams in it, and their threshold for problem is when 4 of the clam sensors have gone off.
Ah, right.
The other thing is, this is humane clam sensorism, because sensing, they have limited the service life of a clam to a 3-month tour of duty. So you get the thing glued to you for 3 months, and after 3 months, they unglue it, they mark it so that they're not going to use a clam again. You can go live the rest of your happy clam life knowing that you have made an impact in the world.
My first hack this week, audio out over a UART with an FTDI USB to its cable. This is a sweet little hack by Conrad Beckman. Basically, FTDI put out a USB to serial cable that ends in something that looks like a microphone jack. And I guess they did it because this kind of 1/8-inch tip ring sleeve, normal stereo jack is a tremendously convenient form factor. And you've got 3 connections, right? You got ground, TX, and RX, ground, left, and right ear. So it makes sense for FTDI to put this out, but it's hilarious that Conrad then says, I wonder if you just plug that in as an audio. You should plug this right into a speaker and see what it sounds like. And so he does, of course. The trick here is that he basically uses a super high data rate. You can run these up to 3 megabits per second, 3 megabaud, and sends special signals to essentially do a pulse density modulation. So the more ones you got, the higher the average voltage is. The fewer ones you've got, the lower the average voltage is going down the line. You should go check out his GitHub for the code here. It's actually really short, really quite readable, and he at least thinks about the problem of what you do with start and stop bits, which with UART are kind of these necessary high and lows that go with every 8 bits of data you send along. And he ends up just not worrying about it all because this one little pip is triggering off at 3 megahertz, and you're not going to hear that anyway. So you put a low pass filter on it, or you hope that whatever device you plug it into has some kind of low pass. Do a little data rate conversion on your audio file, run it through his code, and it will spit out pretty decent audio over your serial port.
So this makes me think about, I think it was just last week on the show, we talked about visualizing a binary file. And like that was one of the ways that you could find the fonts in it. I've seen visualizations before for recognizing whether things are compressed and like what compression was used and whether, they're obfuscated and stuff like that. But I always think about how like audio matters a lot more than video. At least it does to me. Like watching a movie, if the video is so, but the audio is great, you're usually fine with it. But if you go the other way, like a bootleg where the audio is bad, I just cannot watch it. And I think that's because our ears are good at detecting that fidelity. So is anybody doing something like this where they're actually piping out non-audio data in an audio way, and then you're using your ears to monitor what's going on?
Like you used to if you had a super old modem back in the acoustic coupler days. You could hear if this like negotiation that it does at the beginning goes wrong or not.
Right.
And actually, we used to have a flaky enough phone line / phone coupler. I don't even know what the problem was, but sometimes you would call up and they wouldn't sync right and you'd have to do it again.
Yeah.
And as a kid, I used to know what that sounded like.
Yeah, I'm the same way. It wasn't hard, but you could tell like what baud rate it ended up negotiating by the way it sounded, like really easily. Yeah.
Yeah, this idea of kind of one type of data as another, here it's digital data as analog values, is really prime for lots of other hacking. And I did have to think of Ted Yapo's piece that he wrote for us, where he did this with a USB serial adapter and just like used the spurious radio radiation, the RF coming off of this thing, to his advantage. So instead of trying to get pulse density modulation to get audio out of it, he was running the thing so fast and with such high frequency data and maybe amplifying it a little bit that he could get a 1 megahertz carrier out for AM radio, and through a bunch of clever code tweaking could transmit 27 megahertz, high enough to control like a remote control car. It's under your USB serial adapter, just became an SDR. Absolutely go check that one out. It's like the next level version of Conrad's hack here, although Conrad's is significantly more approachable, plug-inable. You'll probably do it after hearing this.
There is an incredible video out from Ben Krasnow this week, and it feels like we're covering every video that he does. But man, when you do such good experiments, people have to look at them. I wrote the article on this one. It's called "Ben Krasnow Measures Human Calorie Consumption by Collecting the quote output," and it is exactly that. Ben has collected his poop to find out how many calories are in it, which is a hilarious thing to make fun of YouTubers for, and he does in the opening of this one. But before you click away or fast forward on the podcast, this is a great scientific method example here, and it is, how do you know what the calorie markings on the back of the packages actually mean, and is your body getting that kind of calories out of them? And Ben does a great job of going into talking about what bomb calorimetry is, the process of burning a sample of foodstuff in a high pressure oxygen environment and then measuring the heat given off by it in order to characterize the calories that are available in that food. And so Ben builds one of these out of a piece of pipe. It's very interesting. He talks about using a Schrader valve, which is like a bicycle valve. He's got a pressure meter, digital pressure meter, just off of DigiKey. He builds his own windows on this and ends up, cutting his own silicone O-rings for it, which is cool. He talks about those O-rings burning and everything about the apparatus is really cool. But Elliot, I want to talk about why the experiment didn't come to a conclusion.
Okay, go for it.
So Ben eats Soylent, which is he calls it like powdered Ensure. It's a milkshake diet type of thing that you can live on. It's got everything that you need in it. But what it does is it lets him measure very accurately what he's putting into his body. And he does it for a week to kind of prime the pipeline, as it were. And then at the end of the week, he collects his poop and freeze dries it so that it's powder, and then measures it in his bomb calorimeter. He ends up finding that his measurement for the Soylent is very close to what the packaging says. But then when he measures the poop, he finds it has 75% of the calories in it that the same amount by weight, a gram of poop versus a gram of Soylent does. And you wouldn't think that that's right. You wouldn't think that so few of those calories have been absorbed in the body. But I'm wondering how you correlate the two amounts together.
Yeah, we were talking about this earlier, and I was taking the naive position that it's got to be the same. And you were taking the position that now I think is totally right, that I'm going to steal your thunder here. Sorry,
no, do it. No, go for it.
Can I?
Yeah.
May I?
Yeah.
You were taking the position, which I think is totally right, that you don't know how many grams going in represent how many grams going out. And I think what you have to do is record all of the Soylent going into him over the week and all of the stuff coming out of him at the same time. Because what you've done is you've measured kind of the burnable content of what's going in and the burnable content of what's going out, but you don't know what fraction of the stuff coming in is coming out.
Right. So let's say you had, 500 grams of Soylent going in. How many grams of dehydrated poop correlates to that? I think that's hard to measure. Now, the other interesting thing in the comments here that people are talking about is, let's say your body converts some of that energy and then it replicates some cells. So it's built some more stuff. There's going to be waste cells, and those waste cells might be dead, but there's stored energy in them. And so coming out of the human body, you're going to have sloughed off cells of an unknown amount that have calories in them. Does that sound right?
I think there's a whole lot of other stuff going on here. Yeah, I think you're probably right.
I bet you could get a PhD in this topic, and I bet a lot of people have. And if we really wanted to know these things, we could find that person or learn the answers ourselves. But for the purpose of this one, it's just really fun to watch the experimentation. Go watch it. You'll love it.
All right, my next hack is a 3D printing hack, or at least it's 3D printing relevant. It is improving cheap ball screws. This is a project that's part of a bigger, really cool looking 3D printer design called Hevort by Mirage C. You're going to have to check this out. His problem here is that expensive ball screws are really expensive, but they have a lot of advantages over kind of traditional trapezoid screws, or God save you if you're a rep or threaded rods. But then the really high-end ball screws are insanely precise and priced accordingly. So you can spend, $1,000 on a set of 3 ball screws to move your Z stage in your 3D printer up and down. Or you can spend kind of $20-$30 on some kind of no-name, no-spec ball screws. And that's what Mirage C does. Problem with the cheap ball screws is that they're rolled instead of ground. And this means that the metal is kind of squeezed together while it's being made. And it's got all sorts of funny stress in it. And especially for the cheap ones, it's incredibly hard to guarantee that they come out perfectly straight. And this shows up in your prints if you directly couple the stage that your prints are on to the ball screws. And in particular, he points out that there's this tug of war between the ball screws and like the smooth rods that you use to try to make your stage go up and down in a nice straight linear motion. Because the ball screws are thicker, probably, than the smooth rods you're using. And so when they wobble, it's going to wobble your stage, and you're going to get funny artifacts in your prints. And this Z wobble is probably one of the oldest imperfections in 3D printing. I know we had real Z wobble problems with our old RepRap Darwin way back in the day. Although that thing also had problems where the axes would seize up as well because it had 4 things. Oh, it was a mess, but it was the beginning.
Like plain threaded rod, like not even precision ground.
Plain threaded rod, yeah. and it was 4 of them, right? Because there was 1 in each corner, and they were held together with a timing belt that went around all of them, so they could be driven by 1 motor. Which sounds good in principle, but it means you have to tension it around the perimeter of this square, and you have to have some way to keep the square from collapsing in on itself at the same time. So you end up, it's a horrible design, but it was the beginning of the revolution. It was copied into the cupcake, the MakerBot cupcake, which had horrible Z-wobble. And then I've seen it even in modern printers because a lot of people will watch that rod and it tends to flop around. And they'll think to themselves, man, that's not a good thing that it's flopping around. It is a good thing. That screw is inaccurate, and you letting it flop around lets your stage go up and down smoothly. It lets the smooth rods win the tug of war. And so a lot of people end up constraining it, and then they're surprised that they have Z-wobble.
Yeah, that's kind of non-intuitive, right?
It's totally non-intuitive. Anyway, now I've talked way too much about the problem. Let's talk about Mirage's awesome solution here, because what he needs then is something that can slide in a plane. So it can slide kind of in the X and Y directions. And so his solution is really sweet. It's done with magnets that then hold ball bearings in between them. So the magnets keep the ball bearings from just rolling away. There are 3 of them, 3 points determine a plane, and then the 2 parts can roll essentially frictionlessly with respect to each other while the magnets kind of constrain them from rolling too far apart, which I love. He implemented this, and then he found that the bottom part of this pair, the part that's attached to the ball screw nut, would actually pivot when the stage was going up or down. So he extended the mount out and put another pair of magnets way out at the other outside. I guess another 2 pairs of magnets way out at the outside to kind of keep them from torquing against each other. And I just love it because A, magnets are awesome. B, it's a totally 3D printed design that fixes a 3D printer problem. And it fixes it in a particularly, aesthetically pleasing and mechanically sound way.
This is one of the times that I really wish we did have a Hackaday lair where all of the writers worked every day, because it'd be great to grab a beer with Joshua Vasquez and see what he thinks of this mechanism.
Right.
Yeah, he's done all of the work with the tool changer on the Jubilee mechanism that we talked about on here. And I looked at this and I'm like, these 2 would be peas in a pod talking about these mechanisms, because it is really brilliant, especially, that the solving of that pivot problem, I think, is the real leap here. I mean, using the magnets in the first place, I think a lot of people would have stopped right there and been like, that's good enough. The other thing in this one that really strikes me is how amazingly great the rendered motion simulation in Fusion is.
Yeah, the rendered motions really sell it. Like watching a little bit of induced screw wobble and then watching his design work around them really lets you understand how this solution works.
Back with the new video is Leo Frenekes, and he is taking LED light fixtures that are not dimmable and making them dimmable. Pretty simple, right, Elliot?
Unless you know how LEDs work.
Yeah, someone in the comments said it's amazing how much more difficult it is to do stuff like this or to make these behave like an incandescent light bulb. Because with an incandescent light bulb, you just turn the voltage down and then
exactly.
it gets dimmer and you're happy about that. But with LED lights, it's a lot more difficult. LEDs are not dimmed, as I'm sure most people listening know. They're not dimmed by limiting voltage. They're dimmed by limiting the duty cycle of which. So you drive them at 100% or you drive them at 0%. 0 would be off, 100% would be on. And you turn them on and off really fast. And then somewhere around there, you're going to get the smoothed out level that you want. I think a really good part of this video is just the rudimentary explanation of how a switch mode power supply works. I really liked that. Leo boiled it down and it makes a lot of sense. And then his example of how you need to turn these on and off is a good one because he says you don't want to turn the power to the switch mode power supply off because if you do, it's going to reset that supply. That supply doesn't come on fast enough in order for you to get a good smooth dimming out of it. And so what you actually need to do is shunt around the LEDs so that the switch mode power supply is still going on. You know, it's going to sense that it doesn't have the voltage drop that it had with the LEDs in it, but that's fine. It knows what to do with that. But by shunting around them, the LEDs are going to go off, and then you can turn the shunt off and have the LEDs come back on, and that can be switched very quickly, and it becomes the pulse width modulation control. The problem is now you've got to hack it into this existing driver circuit.
Yeah, this problem's really great because the driver circuit wants to be a constant current driver, and what you want to do is reduce the current on the LEDs. And so its one purpose is to give them constant current, and you're trying to beat it at its own game. The clever way out of this is then to divert some of this current after the constant current regulator and just send that somewhere else. And this is actually a trick that laser people will know. If you're trying to drive a laser off a constant current power supply and then dim it and brighten it really quickly, you get these horrible voltage spikes in your upstream constant current power supply if you just turn it on and off, and that'll bust a diode laser real quick. And so I've seen this trick before in putting like a MOSFET or something in parallel with a laser and then turning that on and off, or partially on and partially off even, to control the dimming of the laser just by diverting some of the flow this way or letting it go back through. It's a great trick to have up your sleeve, and the rest of his presentation actually elaborates on that.
Now, it's not even as simple as it sounds. I know it's like it doesn't sound simple right now, right? But you actually can run into a problem glitching this if your pulse width modulation happens to fire right at the point where the switcher is hitting 0, and it's going to turn on again, and it won't turn on again until the PWM goes off. And so he actually figures out a way to work around this, which is you synchronize the PWM with the frequency of the switcher. And in order to do that, you need a sync circuit that is a flip-flop, and then you need an AND gate in order to make sure that you're not driving the gate of the MOSFET that is shunting around your LEDs. And he doesn't want to add a whole bunch of components to this. And so he actually figures out that a PIC 16F1454 has a comparator in it that he can use the flip-flop from that comparator as the sync circuit, and is able to build everything that he needs to make sure he's not glitching. I loved seeing the prototype that he had into this because he's using just copper-clad board, and then he's used a scribe or an X-Acto knife or something to cut out the isolation in there. The thing that we haven't talked about, I don't want to go into it now because it's kind of a deeper subject, but he's also taking this opportunity to build the Dolly protocol into this, which is an industry standard protocol for architectural lighting control. And so he spent a lot of time on this, but it's not just going to be a one-off. His plan is whenever he comes across lights that he wants to use in his house that don't have dimming, he's going to be able to drop this right in and have a finished solution.
Lovely. How many doorknob capacitors do you have, Mike?
I have none. How many do you have?
Yeah, also none. You and I can both not make ultra high voltage devices without having capacitors that can withstand this ultra high voltage.
Oh yeah, 12 volts is my limit, Elliot.
Well, that's not going to cut it, my friend. If you are Les, who has been making TEA nitrogen lasers for quite a while now. We've covered 2 or 3 of his other videos. In this case, he is hooking up his own homebrew doorknob caps for high voltage fun. The idea came from actually a previous video of his that we also covered, where he tried to rebuild one of his lasers using just kind of off-the-shelf capacitors. So if you don't know what's going on here, a doorknob capacitor is a capacitor. They're called doorknobs because they're often encased in ceramic, and it looks like a little cylinder, and it's got the contacts coming off of either side of it axially, and they're usually like screw terminals. It turns out they're designed this way for 2 very specific reasons. One, that's the furthest you can get the terminals apart from each other, which minimizes arcing when you get the voltages high enough that they could arc through the air across the space between them. And they're straight into the capacitor axially because that's the minimum inductance path. And when you do these really high voltage capacitor applications, you probably really don't want it ringing. And so you don't want any stray inductance in your capacitor leads. And so what he takes are some cheap capacitors that have the leads coming off kind of in the fat direction. What do you call that direction? No, they go off like spokes on a wheel off of the capacitor body. Anyway, 90 degrees to where you want them to be. And his solution here is awesome. It is to soak these things in acetone for a while until the blue epoxy blob that they're usually dipped in is soft enough that he can peel it off. And then he pulls the leads off and he attaches his own leads. Fun point here, there's silver plating on the whatever crystal it is that makes up the capacitor's dielectric, and if you solder to it, it eats through the silver layer, so he ends up connecting it mechanically. The proof then is in the pudding. The proof of the pudding is in the tasting. He puts one of these homebrew doorknob capacitors into his high voltage TEA laser and gets it up to like 25,000 volts. Whereas before, when he was doing it with the capacitor straight off the shelf, it was arcing across it to quite great effect. If that were on my desk, it would scare the pants off of me at like 17,000 volts. So a puny 17,000 volts. And it looks like the sweet spot for his lasers is something around 20. So it was like tantalizingly close, but then they were arcing over. So he just had to push it over here. And if you've priced out doorknob caps, they're like $100. And he's using off the shelf, like you can order them at Mauser capacitors that cost like $1. So it's worth soaking them in acetone for a week.
First up on my list of quick hacks is beautiful and bouncy RGB LED skirt reacts to movement. Make TV built this skirt and it is awesome. There is kind of an underskirt part where a bunch of LED strips have been attached and then a mesh-like over part. And you can see the LEDs really well through it, but for some reason, like the way that the garment falls, it isn't completely apparent that they're strips. It's done a really good job. I think it might also have to do with the fact that they're closer together at the waist and further apart down at the hem. And this is hooked up to an accelerometer, and so when you jump, you can get like a bouncing ball effect on these, along with a few others. I thought it was an interesting tidbit that there's no strips on the back because you wouldn't be able to sit down in the skirt if there were. Next up, Dynamite Macro Keyboard controls all the things. This is something I definitely need on my desk. It's an e-paper display that has 8 buttons, 4 along one of the long sides and 4 along the other long side. It also has a scroll wheel, and so you can turn the scroll wheel to do different settings, and then the e-paper display will show you an icon of what's going on with each button. I'd love to have something like this to manage like multiple clipboards and that sort of thing on my computer, but I think it's also been a popular thing for managing like OBS Studio and and the different camera views that you're seeing. I think the nice thing about it is it's customizable for whatever you need. And finally, vintage calculator design shows just how much we take for granted today. Amen decided to break down this 1970s calculator, a Rockwell 920, and see if he could get it working again. The problem is the voltages on this, it uses negative 17 volts. And so how do you have equipment to troubleshoot that? Well, the answer is you make your own. You grab a blue pill and you use the negative 17 volts as the ground. You use the 0 volts as the supply, and you start probing around and figuring out if you can fix this circuit.
My first quick hack, techno chic microbit makes cardboard pinball more legit. This is a cardboard-based pinball machine, the Pinbox 3000, done up right. She uses 2 microbits that talk to each other with Bluetooth. It provides tons of crazy feedback, lots of lights. There are some awesome crafting tips here, including she makes a really nice diffuser for the LED sign by cutting things with opaque paper, transparent paper, and kind of gluing them all together into a nice, beautiful looking sign. Tons of tips like that. Next up, how did the Nintendo Virtual Boy work? This one should be a deep dive, but you really just need to go check out the site. Rodrigo Capetti covers it. The Virtual Boy was a failed mid-90s 3D game that I've actually played with. They're surprisingly cool. The coolest thing about it for me is that instead of an LCD screen, it actually had a row of LEDs and a mirror that vibrated up and down to do the rastering for you. Anyway, it was early stereo VR. People complained about getting headaches. I've played one for 10 minutes and thought it was awesome. This write-up tells you everything you could possibly want to know about how the Virtual Boy worked. Last up, Tom Stanton, Pelton turbine development for an air-powered model helicopter. Mike thinks he has my number, and I'll be damned if he isn't right. The idea here is Tom is trying to make a compressed air-driven vehicle and is looking for different turbines to run the compressed air into after putting them through a tiny nozzle. Here he's using a Pelton turbine, which is a classic design for making water wheels. He goes through all the differences between air and water and comes up with his own improved design. But my favorite thing about Pelton turbines is they have these cups that kind of reverse the direction of the water as it flows through them. The thinker here is how fast should the water be moving when it falls out of these cups for maximum energy transfer into the wheel? The answer is it shouldn't be moving at all. Well, the answer is actually more tricky than that, because the water does need to flow out of the way to let the next cup through. So there's always a little potential energy left on the table, but c'est la vie.
Time for our Can't Miss Articles of the Week. This is long-form content written by wonderful Hackaday writers, and I picked one this week by Moritz V. Sievers called A Brief History of Optical Communication. What a joyous jaunt through this topic, Elliot.
Absolutely.
So optical communication, what do you think of? You always think of fiber optics, right?
I think of lasers, and then I also think of, and actually he covered this, I think of the mirror, kind of shine the mirror into the sun thing.
Oh, interesting. Yeah, I think of the ship-to-ship communications where they have like the flappers on front of a powerful light and they do Morse code like that.
Yeah, exactly. That's what I'm talking about. Except the camping emergency version of that you can do with like a regular handheld mirror.
Oh, right, because they have those mirrors with the hole in them.
Yeah.
And then how does that work? You're supposed to like look through the hole at arm's length at a plane?
I've never understood what the hole's for. I think you're supposed to somehow aim onto the plane with that.
Or maybe like you put your hand out in front of you and you put the mirror to your eye and you put your hand in front of the plane and you make sure that your fingers are lit up by the sun. And then the plane...
Oh, that's a good idea. Yeah, exactly.
I bet that's how it works. But that's not what this article's about.
Not at all.
So it is a nice jaunt through this. I didn't realize that the Greeks had mountaintop torches for signaling, a la J.R.R. Tolkien, but obviously where do ideas like that come from? So to the point that there was, they think even like a 5x5 matrix of Greek letters that were you could use the torch setup in order to signal those. It's from a segment called Semaphores and Heliographs that Moritz covers. The really interesting one for me here is the French semaphore towers, which were like a mechanized tower that had like articulated arms on them, and you could do different shapes. Think of like the person with the flags, but this is like a tower. And the interesting thing is the ACK signal, as Moritz puts it, is you would set your tower up with the letter that's currently being transmitted, and you'd watch the next tower down the line. And once they got the letter set up, then you could look to the previous one and start changing your tower again. So you could pass these things down.
Because you know they've gotten the message because you see them send it.
Yeah, absolutely.
Unless you send 2 L's in a row. What if you're saying hello?
Yeah. How
do you tell if they've gotten the next L?
Yeah. How do you say TTYL?
How do you say... yeah.
It's interesting to think about how far we've come with communication, because it feels like there's a very 20th century, weight to it with the digitization. But I think that the cleverness has always been there in these systems. I'm really looking forward to the newest thing that I think is happening right now, which is this satellite to satellite laser-based networks. It feels like, if you compare the telephone system spreading across North America through microwave links, that feels like an inflection point to me. And then if you think about undersea fiber optic networks, like that's an inflection point. And I'm wondering if laser satellite communication is going to be another inflection point that kind of, again, boosts our communication systems forward.
I'm somehow entirely indifferent to laser-based space communication like that, because I think that it's so much easier to run cables on the Earth, except that it's not, because you have all that stuff in the way, and you have to get right-of-way, and you have to ask people if you can bury cables in their yard, literally or figuratively, and that is all a big hassle. So, to me, the lasers in space thing seems like it's just about getting it done cheaply. On the other hand, as far as that means that we'll have lots more data bandwidth because it's done cheaply, maybe you're right.
Well, so I guess I don't know this for sure. It's an assumption that I made, but it seems like laser link communication would have a higher bandwidth than radio-based communication between satellites, because it's very, it's point to point. And so you can have a lot of different satellites in a mesh network doing a lot of different communications at the same time, where if you were on RF, they would be interfering with each other.
Easily could be. I'm comparing it to laser-based communication through fiber optic cables back here on Earth. But I want to say one more thing before we go. I was so happy to see Moritz give a shout out to the Ranja project, which was an old open source circa 2001 point-to-point LED communication system that was entirely DIY and able to put out 10 megabits per second back in 2001. And this was when, 100 megabits per second was the cutting edge Ethernet spec.
While we're on the topic of lasers, let's cut stuff instead of communicating with them.
So Al Williams got himself an Ortur brand laser cutter and wrote up his experience with it in this article, Hands-On with the Ortur Laser Cutter. These things are, they're in the air these days. I don't know why. I think the lasers on them have just gotten cheap enough. It's basically a 2D plotter frame. It's got XY. It's built all on rails. It runs on a couple stepper motors and some timing belt. Basically, I think the reason that they are in everybody's mind is because they're getting made cheaply, and you can pick one of these kits up for kind of $200. They use the blue lasers, the reasonably new high-powered blue lasers that put out kind of 2.5 watts, and if you stack more of these together, you can get kind of different multiples of 2.5 watts, 5 watts, 7.5. I think I've seen even 10-watt ones. They're, of course, all marketed by using the input power, and so they all sound like they're 30 watts even when they're 10. And I'll admit, I actually splurged on one and picked it up for $20 on eBay. Mine was a, quote, 7-watt one that puts out 2.5 watts, and I strapped it onto a CNC, and I will say it's surprisingly fun.
Does it come with the heatsink and cooling system already integrated?
Mine did, yeah.
Wow, that's a great price for that. Although I'll play the safety nut, right? I mean,
oh, dude, me too.
Yeah, what a lot of people are upset about is that these are laser cutters with no enclosure in them. So they put in, a set of supposedly the right wavelength of safety glasses, and that's the entire safety system.
They give you a pair of safety glasses and a pat on the back and say, kid, don't shoot your eye out. It is borderline unconscionable. It's certainly illegal to sell these as a finished product. The loophole here is that you have to screw these things together, so it's officially a kit. If these were sold as a product, they would require them to have a lockout with a switch on it so that only a qualified operator could use it. It would have to be, of course, in an enclosure, but in an enclosure that also has fail-safes on it so that if you lift the enclosure up or open it, it automatically shuts the laser off. These things are made to a price point, and that price point is low because they're taking all of the corners around the security game. On the other hand, if you're a cheap bastard like I am, the solution here to make it 100% safe is just to put a cardboard box around the thing. And if you have a spare webcam, you can mount the spare webcam on the inside. And when the webcam goes blind, you're out $7. And a lot of these lasers have enough power behind them that even looking at reflected light from them, if you get a bad shine, will actually blind you before you can blink. So that's no joke.
Now, what are we going to talk about? Oh, well, let's talk about the smoke. So safety aside, I've been chuckling at your stories over the last 2 weeks about staying up late in the workshop as you would, cutting things on your newly hacked together laser cutter, and then going up to bed and having your wife tell you that something is burning.
Yeah, I hop in bed. She's like, "Do you smell smoke?" And I'm like, it's me, hun. Sorry. I've been at the campfire.
Yeah, ventilation.
The cardboard campfire in the basement. The reason laser cutters have a box around them is it contains the smoke and you can vent it somewhere else. And if you don't have a box around it, the room you are in becomes that box. And yeah, that's the way my workshop smells. I think Al's slowly discovering that. I think the other thing he's discovering is that any kind of burning laser needs air assist to blow the smoke out of the way. Otherwise, the smoke just eats up your power, and actually, air assist also helps blow out fires that may start catching while you're lasering things. The other is that it's nice to have a Z-axis so you can do the focusing. What's nice about these Chinese units is that they have a screw so you can focus the laser to a really good pinpoint on whatever it is you're focusing. But the bummer then is that they have a focal depth of kind of, 3-4 millimeters before it gets unusable again. Whereas if you had a Z-axis on your laser cutter, which a lot of fancier laser cutters do, and mine does by default because I strapped it to a CNC machine that has a Z, it makes calibrating out the focus dead easy. You just draw some lines going up a little bit each time until you get the thinnest line, and then that's your Z height that you pick. So I think Al is going to do, I don't know if this is a spoiler, I think Al's going to modify his laser cutter to add a Z-axis to his El Cheapo.
Yeah, that's a cool hack. I like that one.
And then the last thing I would say about these, when I was reading the comments, a lot of people were doubting and saying, you really need to step up to one of the K40s, the really good infrared lasers. And it certainly is the case that if you want to cut things that are transparent, you can't cut them with a blue laser like this because the laser light just goes through. They're transparent. On the other hand, you definitely can cut plywood with these. And I'm using one of the cheesy 7 watt in quotations that really puts out 2.5 watts. And I cut through some 4 millimeter thick poplar plywood with them. And to do it, I'll say I had to go slow and I had to lower the height on the second pass. But I did it in just 2 passes, which surprised the heck out of me. And yeah, there's a lot of smoke, but it made a really clean cut. So I don't know. I used to be one of these doubters too until I picked up a cheap laser on eBay and did it myself. And I'll be damned if it isn't a completely functional and interesting device. So I expect we'll see a lot more out of these things in the future, and not just people putting pictures of their face and or YouTube channel logo onto pieces of leather.
Well, you know, it's a big jump to go from one of these diode lasers to a tube laser. I mean, it's like
it is.
It's like a bicycle versus a Vespa. You know, like you've got to take care of that tube. Al touches on it actually. You have a water cooling system.
Yep.
Usually for those. I mean, it's you've got a mirror on the end of the gantry because the tube is not moving in both directions.
You've got a ton of optics you need to calibrate and align, and it can get dirty. And
yeah, so I mean, I see, like, you need someone that is going to be the caretaker of one of those tube lasers, and that's why you see them at the hacker spaces, and you have someone who's in charge of the, you know, laser cutter department who is training people on how to upkeep that laser and keep it running. And, you know, the time and expense are worth it because a number of people are using it. I think that unless you have a lot of jobs to be doing, it's hard to justify that in your own home shop. But these diode lasers are a lot less maintenance.
Diodes last forever too if you don't abuse them, whereas the CO2 lasers really do have kind of a limited working life. So it makes you feel like you're paying for every hour of laser cutting time, even though you're not paying all that much for it. I will say that the people who are in favor of the K40s aren't wrong either. And that if one of these little diode things sets you back $200 and one of the significantly fancier CO2 laser ones sets you back $400, you're getting a lot more for your money with the fancier laser because, you know, you've got all these optics. You get the fume solution at least halfway solved for you. A lot of people add extra air to the K40s, but you at least have a box around it with some degree of safety and a vent to put out the window. They can cut a heck of a lot faster because even when you're running them at half their power, which you probably should because they're made to a price point, even when you're just cutting with 20 watts, that's like a lot different from cutting with 2 watts. And cutting with 20 watts in infrared is a lot different from cutting with 2 watts in blue. And they're just a completely more capable machine for not all that much more money. I mean, it's twice as much money, basically. In my shoes, I already had the 3D mechanism. It was just a matter of picking up a cheap laser and strapping it on. And for that, super fun. And if you want a simple and easy project that you can do with one of these lower powered lasers, one of the things that people do that's really cool is to cut paint off things. And that includes mirrors and other pieces of glass. And that makes a fantastically easy way to make a word clock. And in fact, we just ran an article on a laser etched word clock this week. This slimline word clock uses laser etching to keep things simple. Go check it out in the links. It's a beautiful piece of work by TOMG.
That's all the time we have for this episode of the Hackaday podcast. As always, we'd love to hear from you. You can leave a comment on the show notes, which you'll find at hackaday.com/podcast. You can send us an email, editor@hackaday.com. We live and die by the tips that you send us, so if you've done something cool or you see something cool, please let us know about it. tips@hackaday.com. And until next time,
keep on hacking. Freaking nerds, man. I'm gonna drop that one, although I love it.
Good to go?
Blah.
Perfect.
Measuring poop calories.
Thank you. I'm pressing stop.
Do it to it. I'm done talking.